All right, this lesson is going to be about graphing sine and cosine functions, also known as sinusoidal functions. So far what we've done in this unit is that we've learned to define sine and cosine for angles in standard position. And keep in mind that an angle in standard position is one where we start on the positive x-axis and then we move counterclockwise through quadrants 1, 2, 3, and 4. So we are going to measure all of our angles in radians as we've been doing this entire course and as we'll do all the way through this course. And we're going to use the unit circle to evaluate sine and cosine functions and then use those values to put together the graphs, which are periodic in nature. So we're going to start with the sine function. And since we know that the sine function, it deals with the y value or the vertical displacement from the x-axis, we are going to call the horizontal axis of our sine function the radian or angle input value, and then the y value will be the actual y value from the unit circle. It will be the vertical displacement from the x-axis, okay? What we like to do is use some specific input values to help us graph, and you'll see that all those input values are from the 30, 60, 90, and 45, 45, 90. Those are in degrees. Of course, I'm not supposed to be using degrees, but those special right triangles from geometry. So I have pi over 6, pi over 3, pi over 2. Those are the three core families. Well, pi over 4 is one of the core families. For some reason, I don't have it listed here, but that's okay. If we just take the sine value at pi over 6, we come over here to the unit circle, and the y value at pi over 6 is 1/2. So we're going to start to build a table of values, and I'm just pulling from the unit circle, and we'll cycle around the unit circle, pulling the y values that I'm underlining here and inputting them into the table. And it looks like I also need the quadrantal angles for my table. So all of those y values I'll pull in. So I have 1/2, and then I have rad 3 over 2. Pi over 2 maps to 1. 2 pi over 3, using symmetry of the unit circle, maps to rad 3 over 2. 5 pi over 6 goes to 1/2. Pi goes to 0. And notice that these values were all in the first and second quadrant, where the y values are positive because they are on the upper half of the grid above the x-axis. On this second set here, we move down to below the x-axis, so our y values are going to be negative. So I have a negative 1/2. Negative rad 3 over 2, negative 1, again negative rad 3 over 2, again negative 1/2, and then when I come back to 2 pi, my y value is 0. So I can take these table of values and I can just plot them on a grid. So I start with sine of 0 is 0, sine of pi over 6 is 1/2, sine of pi over 3 is rad 3 over 2, and if you think about rad 3 over 2, rad 3 is approximately 1.7, and when I divide that by 2, I get about 0.85, so we're going to get close to 1 but not quite to 1. Pi over 2 does graph to 1, and then I use 2 pi over 3 to rad 3 over 2, 5 pi over 6 to 1/2, pi goes to 0, and then I'm going to do the flip side underneath the x-axis for my negative values, and again I am just graphing in the y values from the unit circle that I took from the unit circle and put in the table. And do you see this shape here that I'm going to have trouble graphing? But this is a sinusoidal graph. It's this nice curved graph. You're going to see that the graph is concave down from 0 to pi and then concave up from pi to 2 pi. Alrighty. So the properties of the graph of the sine function. You can see here a nicely drawn graph that somebody did with a computer instead of by hand. But you'll notice that for the graph of sine, we have something called a midline, which is halfway in between the max and the min values. So here's our max value up at 1. Our min value is down at -1. So the midline right here is the x-axis. That is the line y equals 0. Midline literally means average of max and min values, or midway through the max and min values. The amplitude is the distance from the midline to the max, so this distance right here, also the same as the distance from the midline to the min. Because it's a distance, it has no sign, it is always going to be positive. When I say has no sign, I mean S-I-G-N sign. So the amplitude of your standard sine function is 1. The period, P, is 2 pi because that is 1 full revolution around the unit circle. Frequency is the reciprocal of period. It is 1 over 2 pi, and it tells you how much of a unit circle you get through in 1 radian. So since it takes 2 pi radians to get through a full revolution or a full cycle, you get through 1 full cycle in you get through 1 over 2 pi components of a cycle per radian. Okay, and then you notice here what I already said was that sine oscillates between concave up and concave down. We start concave down from 0 to pi, then we go concave up from 0 to 2 pi. Okay, so we can do the same thing for cosine, except for cosine we're going to use the x values of all these unit circle values. And I'm underlining them all here on the unit circle. And then I'm going to bring them over onto our table. So I start with rad 3 over 2, then 1/2. Pi over 2 maps to 0 for cosine. Now notice that 2 pi over 3 and 5 pi over 6 are both negative because cosine is negative in the second quadrant. Cosine of pi is -1. 7 pi over 6 also negative because cosine is negative in the third quadrant as well. Cosine of 3 pi over 2 is 0. Now in the fourth quadrant, cosine is positive. So I have 1/2 and rad 3 over 2, and cosine of 2 pi is 1. I can take those values and plot them on the graph. And can you see that I already made a mistake? I started to graph sine there, and I don't want to graph sine. So I'm going to start up here at the point 0, 1. Pi over 6 graphs to rad 3 over 2, which remember is close to 1, but not quite up at 1. Pi over 3 maps to 1/2. Pi over 2 to 0. 2 pi over 3 to -1/2. Then negative rad 3 over 2, -1, and I'll keep on cycling through. And you'll notice that just like with the sine curve, I have this lovely smooth arced curve, except this one started at a y value of 1 and decreases, hits its bottom, and then increases again. So this graph is actually concave down from 0 to pi over 2, concave up from pi over 2 to 3 pi over 2, concave down from 3 pi over 2 to 2 pi. So the key properties of the cosine graph. First of all, we have a midline again. The midline is still half the distance from the min to the max. The max is still 1. The min is still -1. So your midline is still here on the x-axis, the line y equals 0. Amplitude is still the distance from the midline to the min and the midline to the max. So the amplitude of your core cosine function is 1, just like the sine function. Period is 2 pi because it still takes us 2 pi to get around the unit circle. Frequency is still 1 over 2 pi. And cosine still oscillates between concave down and concave up. So these properties are really the same for sine and cosine. The big difference between sine and cosine is that they are horizontal shifts of each other. So notice that the cosine function starts off at a +1 on the x-axis, or on the y-axis, excuse me, whereas the sine function, going back to that graph, starts off at 0. If you took this sine function and you took this point right here and pushed it to the left by pi over 2, you would end up getting the cosine function. So that gives us this relationship between sine and cosine, is that they're both sinusoidal. They both involve additive and multiplicative transformations, or they can. We don't have that yet. We're going to do that in the next lesson. But this is the key here, is that cosine is really the sine curve. Sine has to be shifted left by pi over 2. That will get us the cosine graph. Okay, so that positive here means a shift. I shouldn't put that there. It looks like a negative if I circle it. That positive there means sine is shifted left to become cosine. Okay, so here are 2 periods of some sinusoidal function. We need to identify period, frequency, midline, and amplitude. I think the easiest way to identify period is to go, you could go from max to max, Those are not on tick marks, so that might not be the easiest way here. We could go from min to min, again, not on tick marks, so maybe not the easiest way. But we could go from where we intersect the midline to the second place where we intersect the midline. So that cycle goes from 0 to pi to get through one full period, which I can graph out a full period here. Not well, apparently, but there we go, that's better. So my period here is pi. Frequency is the reciprocal of period, so just 1 over pi. Notice how my graph is shifted up here. So my midline, which is halfway between the max and the max is at 6, the min is at 0, so the midline is the line y equals 3. And the amplitude, recall, is the distance from the midline to the max or the midline to the min, and those distances are 6 minus 3 or 3 minus 0. Either way, the midline is 3. I'm sorry, the amplitude. The amplitude is the distance from the max to the midline or the midline to the min. Those distances are 3, so the amplitude is 3. Here, it looks like we've got, I think it's easiest to go max to max, or because these cross tick marks here, I don't think the midline would be easy to handle, nor would the mins. So I would go max to max here and see that one period, draw it in here, takes place in pi over 2. Frequency is 1 over period, and 1 over pi over 2 is 2 over pi. Midline, remember it cuts the graph in half vertically, so there's my midline, that's at y equals 1. And amplitude is the distance from the max to the midline or the midline to the min, so that distance here is 2. That is my amplitude value. Okay, so here's another problem. We have a sinusoidal function that has a max at this point, and the first minimum after that point is here. So if I were to graph that, I would say that at pi, I map to 8, and then at 3 pi, I map to negative 2. That's this component here. It doesn't include this component moving up. So basically, I've got half a cycle here. So if half the cycle is from pi to 3 pi, half the cycle is 2 pi, and that means the full cycle, or the full period, is 4 pi, and the frequency is its reciprocal. Now the midline is the average between the max value and the min value. The max is 8, the min is negative 2, the average, just add them together and divide by 2, so that midline is the line y equals 3. And then the amplitude is the distance between 8 and 3, or between negative 2 and 3, so that amplitude is 5. Okay, so we're going to then go back to the task model that we talked about earlier in this unit. So we have here, if you recall, we have a distance from the floor to the middle of the clock is 120. We also said that the unit hand was 8 inches long. We did this on the very first day of Unit 3A. So let's see if we can remember a little bit. We said at time equals 0, the minute hand is directly up at the 12. So that distance is actually at 128. And when it's down here at the 6, it's at 112. Because remember, this height here is 120. So we add 8 to the max and subtract 8 to get to the min. That means our midline, we can now put a name on it. The midline is y equals 120, okay? You should also notice that the amplitude then is 8, that is the length of the minute hand, okay? So remember that this clock is not working properly, and we have a situation where it runs through a full cycle in only 30 minutes. So if you recall, that means that the period is 30 minutes, which would mean the frequency is 1 over 30. Okay, so we were asked at the beginning of the unit, even without knowing any trigonometry, we were saying, hey, can we plot these points? Well, we know at the midline, we're at 120. That's for G and K. For F and P, our max is at 128, and our min here is at 112. Now, I always do my y values first. Some people do them in conjunction, the x, y together. Some people do the x values first. Doesn't matter. Notice at time equals 12, they're telling us we're at the max. The clock is pointed directly up. So that means our time equals 0 is right here. And recall that our full period is 30 minutes, so we'll be back at the max at 30 minutes. So halfway between the min and the max, which is at 15 minutes, halfway in between the two maximums will be at the minimum, that's 15 minutes.